Yeah. So today, the continuation. Uh, Today we are going to start about the agents. Okay. So AI agents, because things going to be in chain process with our AI agents of whatever we discussed previously. Now, if you understand, we know already the Google definitions, what is AI agent and all, but exactly what it, how it is placing into the enterprise systems, company, organization, platforms. How exactly it is going over there and doing over there. We need to understand that. Okay. See, AI agent means we are using LLM under the hood. LLM under the hood. Think of ChatGPT. Think of ChatGPT. Think of any cloud. Satish sir, you are drawing something on my screen. So, yeah. So, ChatGPT, if you ask some question like, hey, what is the problem by looking when you're looking at the when you or look at the logs? The ChatGPT will answer you to your question saying that there is a problem in API container CPU or container CPU usage like this. But it will tell you you should go and increase should go and increase CPU like this. Go and increase CPU like this. It will tell you, but this will not take any action. It will not take any action. It will not take any action. That means it will never execute. What you give as a text input, text output you will get with your chat GPT. So chat GPT is normal like a chatbot by using LLM your brain. Okay. So it will only tells you that. In our body, how our brain is, it will take inputs and it will give you outputs. But things are not getting executed. Now think of an AI agent. Agent means if you are a human being, if you are a human being, if you are a human being, human being, so let me take user image. Think of you are a human being and you have all your legs and hands, shoulders, all this, right? You will be having legs here, shoulders here like this. Sorry for this diagram, but if you say your brain is working on intelligence, whatever something you have input, you can able to decide, do, apply your intelligence, and then you have an output answer. But you will be giving an instruction to your leg and your hand and your other part of your body to execute, to do something, right? You are going to do something. My brain is saying something to my hand, then my hand is writing this arrow because I have input. Some process is going on in my brain. My brain is commanding to my hand is doing this. So similar way, you are an engineer. You are an engineer on a infra, on a infra or a application side. On behalf of you, agent will work for you on some extent. and some extent it will work on behalf of you. Example, when the same question you have asked to, what happens when you're looking at the logs? What happens when the looking at the logs? It is telling you the answer. Instead of telling the answer, instead of telling the answer, it need to be follow one flow. One flow. So it will follow one flow and then it will execute it. It will take an action and it will execute it. So that the CPU increase things will be done by your agent, not by you. Is it recommendable at the production level? We'll come to that point in the later. But understand that AI agents are doing this kind of activity. So now you can call it as agentic automation. This is an automation only, right? Agentic automation. Agent, if you are writing CI/CD pipeline, that is an automation. Then why not this agent is an automation? Because with you, whatever you are telling as a goal, as an input you are giving, so it is following a flow. Then it will do a planning, task breakdowns, memory checks, many things are there. So it will do a flow and then it will execute it. Then it will execute it. Example, I have the same user. I have same user. User is sitting with my laptop. User is sitting with my laptop. Okay. So this user said something in my laptop that so he would like to execute something. He would like to fetch something. Some issues came here. User will give a goal. So this will take a goal. This is our goal to your agent. To your agent. After your goal, this is a flow. Now what happens? It will do a plan. Plan. Okay. After nothing but planner. Okay. So after this, it will do a task breakdown. After this, it will do a memory check. Is it temporary or long term or a short term like that? And then it will do a content classification or a content context. It will also come to your intent classification also. But now collection of context. What context and what context you are trying to do. Here is comes tools. Okay. It will select tool according to your context. Then it will select a tool and then it will execute. Then it will execute. Now let me little bit drag it. So I'll keep this process in the down now. Okay. After this, what it will do, it will observe. This is the ideal things. It will observe. Then after it will do reasoning. Okay. Reasoning. Then after it will take a decision. I'm telling the ideal agent how it should work. Again, it's on us that which components we would like to keep it. And then take an action. Then take an action. And then validate the action. And then final response. Final response. So this is how your flow would be, your response will come to your user again. So this is how the agent will look like. If you ask me how really the core flow will be, agent core flow will be, I'll tell you that. Understand this process I would like to use in one of my company or in one of your project in the infra level or application level, product level, whatever. So when you are planning your agent, we should have this knowledge. So where do I call this and what steps I need to or what components I need to. So first of all, we need to discuss about the components. What components? Main components. The first component is your brain, agent brain. Okay, that means LLM. So this LLM is nothing but your GPT. You can take it from OpenAI. You can take it from also cloud, or you can also take it from the Gemini. It's up to you or your Llama. Okay, so like this. So here what happens? Here you are doing making a decisions, making a decisions by using your brain. So this is one thing, first component. Second component is tools. Second component is tools like your hands and legs for easy analogy. Example, you have your API. Example, you have your Jira or Slack or your DB or your Prometheus, Loki, maybe anything, or shell commands, okay, or queries, some of the queries that you wanted to run, queries that you wanted to run. So this is comes into the tools. And the third thing is your memory. Memory. So memory is like your experience. We have our experience, right? Memory nothing but experience only, right? We will store all the things in it in two forms. One is short term memory. Short term memory means it works on only current task. Long term memory, that means nothing but our vector. We use vector DB like Pinecone, Millius, like this. We use some vector DB for the long term memory. And then we will be having what's our planner. Planner like thinking. So in thinking there are different techniques are there. So I'll tell you that going forward, what we'll be doing, we'll break the big task into a small task. We'll break the big task into a small task. Whenever you ask and keep it thinking in ChatGPT or cloud or anywhere, thinking enabled means your prompt turns into something. Your prompt turns into something that you can also see how optimizedly that prompt will be turned. So that is planner. And then finally executor. Finally executor. This is a main components. Executors. Nothing but you can call it as action. So it will runs command like this I can say. It runs actual commands. Think of an example in the real time. Okay. I was saying that, hey, there is a API API latency. So this goal taken by your brain, and then what my agent will be doing, it will be taking a decision that okay, when API latency is down from the user level of the input, then Claude will be or Gemini will be asking you, can you please provide some logs? What question will arise from here? Can you provide logs of your error, right? So if I go to ChatGPT and directly ask API latency, API latency is high. So when I say thinking, so this thinking, then it is saying that okay, API latency is high means user are getting slow response from the application. I will troubleshoot by a layer. So it asks, I don't directly assume the application is bad. First identify whether latency is coming from app, DB, dependency, network, something like that. To ensure, find out the bottleneck and apply the proper fix. So immediately what you will be doing, now it is a very generalized chat GPT. When I ask in a global way, it is understanding from my long term memory, because I every day do chat, right? I every day do chat, my infrastructure on the Kubernetes only. So most of the times I will be communicating on the Kubernetes. Since my chat GPT is maintaining some long term memory with it, and it is maintaining persona with me, like my tone, how the chat GPT should reply back to us, that also you can change it, and it will understand your behavior. It is also having my behavior recorded with the chat GPT. So based on that, it is directly suggesting me on the kubectl commands. But if you ask in your case, it will tell you something else. But at the enterprise level, switching off this different context is not good, right? You need to set up a prompt to your LLM that, hey, whenever any user given any question like this, think like you are a infra engineer. You are a senior infra engineer. So when a senior infra engineer directly ask a question, what the next question will come to you? What are you talking about? Can you provide me some logs so that I can tell you what exactly gone wrong? That is a question will come to you, right? From our senior. Same way, the question will come here like that only. Can you provide me a logs of an error so that I can guide you better? So when this is comes, you should provide some logs. But I'm not in a loop. Human loop is not here. I'm saying that agent should do this all. So this question will be triggered to your tools, to your tools. Then it will decide that connecting to the tools and forming a context, then connecting tools, forming a context, get the logs. First get the logs. API. That means we need to provide some routing here, some tool connection mechanism here. So when we provide like that, tools are here, right? My Prometheus is there. So it will go to my Loki. It will go to my Prometheus. It will go to my maybe your CI/CD pipelines. Any recent deployment logs are there. So it will collect this information on average time. You should give an average time. It will be going to collect like 30 minutes an average time maybe when you ask. Okay, you should say some timestamp. At this particular time it is API latency is high. From last 1 hour I'm observing. So that 1 hour query it will keep. Your LLM only will form this query because it is having a context. It will form that. Then This query will be going to run by your agent. Where? In your Loki, in your Grafana. You are connecting the Grafana, right? Then all these things will be stored in your memory. For the next time when you ask, it will be there. Then whatever the logs you came, it will think. It will think, and then it will finalize the answer. It will finalize the answer, like you should increase CPU. When you say this, your executor will execute this action. So it will do edit by running kubectl command, then it will save it. But this is dangerous. There are agents, we use it for most of the times fetching, not writing. We use it for only fetch purpose, redo purpose, not take an action, write purpose we are not using. So there is a control mechanism, agent level control mechanism you can use. So with that, you can do all these things. Yes, there are many agents in the big companies are running already, but they are not publicly available in the internet. None of the company will not tell you what agents they are running inside the company. There are many agents are running. Nobody will not publish in the internet. At the hype, at the agent side, we are only seeing few things like N8N agents. These are all social media things. Okay. But at enterprise level, because they have a sensitive information, so if they might know this frameworks and libraries can be attacked. So that's why things will be not published outside. There are many agents using inside the companies. So this is main components how exactly an agent will work by using my LLM. So this is the core concept. This is a core concept. If you ask me which companies, if you take any large US based companies, insurance companies, many companies are using called Swarm. Okay, Swarm agents. Like there are, I can give you an examples. There are many refactor legacy things are there in COBOL, in Java, in .NET, right? These are many big frameworks on the stacks like Java 17, .NET 8, Python 3.2, like this. So they will be using in their GitLab and GitHub instances, in their GitHub instances, big companies, because these things are meant for their coding system, right? They would be having an agents like scanner agent. So what it will doing, it will pass the code and build dependency graph. Okay. You will be having a planner agent. It will propose migration. Okay. And also it will do risk scoring into your security. And also you have executor agent. So it write the code changes after PR done. But this is human loop. Human loop in agents also there. And reviewer agent. Like it will run unit test, and then security scannings, fixes, all it will tell you. I'm just telling at the code level, these things will be there, but these agents will not be published outside. No company will not tell you that we are using this, that, and all. So if these things can done by the human, it will take a 6 months of time period for them, right? So these are the agents in the company we use. This is a use case I'm telling. So we can use an agent like scanner agent, planner agent, all this in a swarm of type. If you ask me a real-time example, a real-time example, I take any company, enterprise company, a SaaS companies. So what happens like maybe Salesforce, Workday, ServiceNow. We know, right? Salesforce, Workday also there, ServiceNow. They don't publish any of their agents because they use private LLMs, private based LLMs. Okay. In their companies, many companies are actually having a deal with these companies, right? Which companies? Workday, ServiceNow, and Zero also, and uh, I said right, Salesforce. So these companies will be there, right? So many companies will have a deal with it. So they run a private based LLM procurement agents. You know. So what these agents will be having a capabilities like this should not be a public, but I'm telling it's a not things are okay, fine. It's up to any company. Like so, you might be having your startup company. You will be doing the same thing. You define your own flow, agent flow, own capabilities, right? Maybe a master service agreement, okay, or NDA agreement, or statement of work SWO agreement uh, with your suppliers or vendors. This is your system you wanted to do, right? Fully autonomously you wanted to run it. So this is maybe you can do a negotiations on the service agreement. So this kind of an agent to be fully automated. So what your agent will be doing, an example I'm telling, agent workflow should look like this if you're planning like this. The first one is receive vendors proposed contracts. Vendor proposed contracts. You go with any big companies, they have a contracts, right, and you can what it will be doing, you have a flow like compare against 10,000 or 10K plus internal contracts and templates and past deals, like in old deals. Second step. Third is like you do an identify non-standard 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 in the sense in the company side, maybe indemnity, liability caps, terminations, these things you can use, right, in your company side. And then propose a counter propose a counter maybe any clauses are there. I'm just giving a business agent workflow. And then do a negotiation, then do a negotiations, like maybe you can send via a mail of, or you have a portal, right? Every company will be having a portal. Then if it is no response, escalate to the human level where a human can call to that vendor and do this. So what happens whenever a human or a vendor will come and he will fill his application, or they have consultants, right? Consultants will onboard the customers or vendors into the portal. They do all such kind of information filling, and automatically this contract will be generated automatically, right? In the behind the scene, Adobe will be connected. That PDF, those things and all, submitting into your procurement portal side. It's connect through the your workday also, right? So these invoices things will be happen at the banking level and all. There are agents, buddy, behind. Previously APIs, it's a big thing, but now agents are working right now. Companies already. So it is doing very good job. People are thinking like what we do with the agents is not good. No, agents is maybe not good at your infra side, production systems, but at customer side. Think at the customer side. You are giving all these rules, what it has to be worked. You're clearly giving an intention over there that you should work like this. It will work. You can see the flow. Then in the final you have a human loop. Then you have a human loop. So I can also give you like maybe retail and logistics side, your Walmart or your DHL companies, how it will be using like DHL, Walmart, uh, Target, these companies, how they will use, support swarm agents, real world use cases. I'm telling you can give capabilities here in a natural language where user can ask some questions, right? When you go to Amazon, you're asking where is my shipping shipping. Then it will ask you some questions. Are you referring for which order? A recent order, 2 days back order, 3 days back order, 4 days back order, list of orders it will fetch, right? And then first what happens whenever you give, there is an agent like query understanding agent, which will convert your text into SQL query or API call. SQL query or API call. Then what happens? Context agent. Context agent again. Fetch user details. This is already there with Amazon. Okay. Role, permissions, recent activity. As I said, right? Recent activity. All this it will find a context. Then execution agent. What this execution agent will be? It will run a query against your DB as a fetch only, like select star, this, that, and you have a information. It will come and output over there. Then action. Now the action is like it is a support, right? It is a support. So you will be writing some actions like offer buttons. This is how the companies are doing offer buttons. That means reroute, reroute, reroute your shipment. You ask this query means you have some concern, right? Reroute your shipment, or maybe you have some things like, right? So approve time off, maybe like some other timings, things you wanted to do, right? So these kind of questions it will give you in the last. Okay, to take an agent like now your human is involved here. Directly it will tell you some answer that It will be checking your inventory, DB details and everything, and it will craft an answer to you that, okay, because of this thing, it was stuck here. It is on the movement of this area like this. But it will having complete information. At customer level, you are already providing this kind of information. So because of this, what happened? What happened? Users are increased their visibility, right? About their order, the visibility came. Previously, how user should call to the this IVR phone calls. Then it will go to the connect. We need to in the queue. Then they will answer. We need to wait for 30 minutes. Then they will answer. After that, I'll get an answer from them. That because of this issue. And if I say something also, they cannot take anything. The only support BPO peoples will be kept over there to deal the customer, to deal with customer frustration. That's it. So anything that you complained, they will just take a record, but they never do anything after that. If something else, they do some escalation. But now you have an agent, right? He's doing the same thing for you. You get your minimum information here already. You get your minimum information already. When you're comparing a company of doing this thing and doing that thing, it's in a very cheap. This this project is done. Comparing with this, your support agent folks you are keeping over there. Okay, like this. Maybe there are chain of agents also there. Okay, chain of agents like if we are using a payment process, a big companies like phone pay, UPI, we are doing right. Fraud detection we are already doing right. Social media side also doing right. So here also we have some agents. So agents are backend system are running many companies. Don't think everything right now is going with the APIs. Under the hood, agents are doing many things. Many where agents are there. Nowadays, we are implementing use case level. We are implementing a use case level. So we have a types of agents. We have types of agents. I would say, I would say, example, um, this is an interview question. People will be asking, hey, like, can you tell me agent architecture patterns? What are the patterns that you use? Router, uh, router worker pattern. Okay, this is one thing. Second thing is like supervisor, supervisor, supervisor and executor pattern. And third thing is like human in loop. Fourth thing. So these are the three patterns that you can use for your enterprise level: router, worker, supervisor, executor, human in loop. Router worker pattern means this will be advanced concept again. This will be an advanced concept. We'll come to this because when I'm building an agent, when we are connecting a tools, types of patterns we can discuss. Types of patterns we can discuss. But let's understand now there are types of agents. There are types of agents again. So like reactive agent. First you understand react agent. So in this react agent, there is no memory. So it will give you immediate speed response. Immediate speed response. You have goal-based agent. You have goal-based agent. You have learning-based agent. And you have multi-agent. and you have multi-agent system. So these are the types of agents. These are the types of agent. Once we have types of agent, we can go with the types of pattern. Once you have a good understanding on the agent things, type things, we go with the patterns is at your infra or at your platform level, what platform you're using, what is your use case. Based on your use case that you are deploying over the product, right, you're deploying over your organization environment, accordingly you can go with the pattern. It's not like something this is already a designed pattern that we wanted to use this template and run it. No, it's in our hand. We are calling with these names, but we can also modify it. We can add some additional components to it. It's in our hand that how to do this. There is no ready-made template. We'll take it and we'll run it like Helm chart. These are in our hand, that how you are planning at your business level. You can do that. So these are the patterns. So when you wanted to build, when you wanted to build, you have some orchestrators for your agents. Yeah. So agent orchestrators. Okay. Maybe you can take agent architecture diagram. You have agent architecture orchestrations like LangChain. What is LangChain? First of all, what is LangChain? LangChain will work on your LLM application framework actually. That means it is used to connect your LLM plus with your prompts plus your tools, API, and memory. So this is the use case. Okay, a LangChain. And then we have one more called LangGraph, Lang ecosystem completely. So LangGraph side, it's a agent workflow orchestration. You can develop your workflow. Like we can build an agent in a step-by-step manner. Step-by-step manner. That we need to understand. And Langsmith. So what this Langsmith? It's an observability tool or a testing tool, you can say. Okay, testing platform like debug, traces, like our Langfuse we use, right? So LLM level and agent monitoring, behavior monitoring. Okay, like this Langsmith. And you have Llama Disk. So this is a RAG data framework actually, I would say. Data framework one. Yeah. Okay. That means you have PDF, you have Notion pages, you have DB, or you have all this. It will connect to your LLMs. You can use Llama Disk. Similar way, you have Crew AI. Again, Crew AI is a multi-agent thing. You can create multiple agents, and you can give roles. Researcher, like this. Researcher, writer, reviewer, like this. You can give a roles to your agent. Autogen, it is also one more thing, platform. It is also multi-agent thing only from Microsoft. So it will help you in agent talking. The good advantage, each agent to each other agent can talk and solve the problem. And you have this called uh, haystack. Yeah, haystack. Haystack also there. It's an open source again, RAG. Okay, open source RAG agent framework, enterprise level. Okay. So these are the things. At native side, we have ADK from the Google. Bedrock side, we have AWS. AI Foundry, we have from the Microsoft. We can use them to build our agent. So we need to have this agent theoretical knowledge first, so that we will be not having any confusion for further. So that's why I was saying this, and I can give you a real time diagram, maybe like this. So which is I just it almost real time only, but I made some modifications with my hand. So there are some things I rewrite in all these names. It at business area understand. First, when when uh, when a user customer asks something at your UI, you go to a Vanguard portal and ask what is my portfolio. You go to any Citibank or anything, you just ask something. First, it will connect with your API gateway, agent endpoint. Then agent orchestrator. You might use Autogen, you might use anything. So it will be their AI agent. Then this AI agent will connect first intent understanding. What is your intention? Intent classification. Then it will get into the planning. Then it will get into the planning. Does it need any tool first? So this is what it will do a validation. Yes. Then tool router. This is important. Tool router. It will connect to the database, connect into observability, connect to the cloud, Kubernetes, GitHub. I replace these things with original things. Okay. Here there are other pillars, but I'm keeping this. There are knowledge based pillars, other pillars. Okay. So whatever it is connected, you will be having one result, right? If this is an S, you're having one result. So this result will be taken like if you are having 0 also, or yeah, 0 also, like this. You have these results, that's fine. Now these results will go to your agent. Will go to your agent. With this, it will come to your prompt builder. Prompt builder. So it will build a prompt by using context, memory, tool output. Context, memory, tool output. Then it will give you to your Gemini or your Claude. Then here it will do a reasoning. So when it is doing a reasoning, agent observability things will be calculated here from your Langfuse. I shown you in the last class. So whatever the input token cost, output token cost, all those things will be calculated automatically because we provide an SDK here. Automatically it will be uploaded here. Okay. After this reasoning, you have some information. Safe correct. If safe correct no, then use guardrail layer. Whether any PII security things happen or hallucination check happen. This is a validator again. In this validator, we can use a small LLM like HiQ or your SLM model for this validation check. It is whether it is safe or correct or not. In last class we seen in observability class, right? We can keep a small SLM model here. You can do that. If it is yes, okay, action required. Action required like execute, approved, action will take. What, when, why. If it is no, it need a final answer to the user. It will provide an answer to the user. Okay, this is how it happens. So when a planning engine is happening here, after your intent classification, a planning engine is happening here. So the planning is approved, then your data ingestion pipeline will store all these things into your DB for your memory purpose. For your memory purpose. Okay. And then all this metadata stored in metadata store, and all will be used in memory, long term or a short term. This is how chat GPT also works exactly. But more areas, layers are added. But at generic level, I'm telling you, this is this is complete your agent. This is your complete. An agent is an application again. You are building many areas. API you are maintaining, AI architecture you are maintaining, this model you are maintaining, this connectors you are maintaining, this LLM you are maintaining, your memory things also you are maintaining on the Kubernetes. This meta Redis things also you are maybe metadata store you are maintaining over there. You are connecting all these tools, right? Your backend system will be there, not only the front end. Your backend system also will be there here. Okay. Who need AI agent will not take over your job. To maintain these agents, they need your job again as a AI agentic engineer, AI engineer. So in the software industry, there is a new application is added. We have a saying, right? Like if plus one minus one. So something is getting minus, that means something is plus adding, right? And software industry, that is the linear thing. From the 2 decades we are seeing, something is minus means something is plus. Now something is minus, that support jobs are went repetitive, like this BPO call support mail chat. These jobs are gone. That means there are other jobs to maintain, like human in loop. Customers will be not satisfied with agent all the time. Customer will be only for initial information is okay, but the next level information he won't satisfied as a human. We know that. None of the companies not maintaining like that. So this is the starting phase. People will be realizing, and then again they are appointing one more engineers to handle this kind of cases. At the software level, development level, people are thinking like jobs are gone, but something is minus your skill or an application, something is automated. That automation is get done by some tool only, right? Get done by some tool only. Example I will tell you. Previously, people are used to deploy manually these middleware engineers. Manually, we need to deploy the code into the servers. Manually, we need to deploy the code into servers. There is Jenkins came, right? Jenkins came. That is an automation. So people are thinking Jenkins came. This manual job's gone because two engineers, three engineers are doing this job. If one engineer came and maintaining Jenkins, that's it, right? Two engineers jobs gone. But what happened over the period? It's just it's just a saying. It just create the rumors like that. People will never think about the future. Now we need an engineers to configure that automation in the Jenkins. We need an engineers to maintain the Jenkins. Now forget about who developed the Jenkins. You are not working for the Jenkins product. You are using the Jenkins, but you are still working on automation. How to do automation with the Jenkins? Still, people don't know 100% Jenkins. What the product developers are developed. Similar way like GitHub also. Similar way like any open source tool you can take. None of the engineers is not 100% using any tool. Still we are trying to use an automated way, right? Something is minus means something is plus. Your work efforts are adding on the plus level only. So like that we need to move with the industry. Agents also same. Who will maintain this entire setup? Tell me. We need an engineer again. Who will agent is not self agent. One agent is not there to maintain another agent. We need an engineer to maintain these two agents. Agents are automation, guys. AI now market is moving into AI automations, applied intelligence AI automations. So, yeah, that is the context I would like to give. That's why if you have a very good clarity, then we're going to with the quick lab agent labs, and I will take step by step as per syllabus, like connecting the MCPs, connecting the APIs, developing an agent in private agents. You can also take agents, you can call whatever the name, but you should clear with your problem statement and the environment. Then you can plan an agent. Creating an agent is not uh, big deal. Okay, at environment level, how your agent should play, the design is the matter. The design is the matter, and connecting flow is the matter. That we need to know. Then you are an AI agentic engineer. Getting, sir? Okay.
Recording stopped.